All right, geometry. We are getting ready for our Chapter 6 test. So this is the review for that. It's over polygons. This first section talks about the sum of interior angles. So if you recall back to that, the sum of the interior angles is just 180 times how many triangles there's going to be. And how many triangles there are depends on how many sides. So the number of sides and then minus 2. So if there's, for instance, number 1, find the sum of the measures of the interior angles of a convex 22-gon. That's going to be 180 times 22 minus 2. So that's going to be 180 times 20, which, use your calculator, 180 times 20 is 3,600. And that would be your sum of the angles. Okay, so for this first video, we're going to go through the odds, and then the other video, I'm going to do the evens. Okay, so make sure to probably watch through both of those videos to be fully prepared for the test. So if you're looking at number 3 now, what is the sum? So I'll just call this the odds video. Okay, so what's the sum of the measures of the exterior angles? So if you recall with exterior angles, they always add up to 360 degrees. So what's the sum of the measures of a convex 11-gon? It doesn't really matter what that is. It's going to be 360 no matter what. Okay. All right. So moving on to the next odd, that's number 5. So it says, how many sides does a regular polygon have? Remember, regular polygon means they're all the same measure. How many sides does it have if one exterior angle has a measure of 5 degrees? So remember, if it's an exterior angle of 5 degrees, okay, that means that this exterior angle of whatever polygon it is 5 degrees, which makes this 175. Okay, so if that's the case, we need to figure out, well, how many sides is going to be? Well, the total amount, so I didn't really need this information over here, but that's just for future reference. It's 360 degrees times, or equals, how many sides times 5. Well, to figure out how many sides, you just divide by 5 to both sides, and you get n equals 360 divided by 5 is a total of 72 sides. Okay, and that's it. So moving on to the next part, and again, that all has to do with the fact that exterior angles have 360 as their sum. So number 7, it says the coordinates of the vertices of a quadrilateral are hi, j, k, and there's your points. Is this quadrilateral a parallelogram? Show your work to explain. So remember, to be a parallelogram, the opposite sides have to be parallel, or same slope. Okay, so all we have to do here is what we did last week, which is find the slope between opposite sides. So the first thing I'm going to do is draw myself H, I, J, K. And now I'm going to find those sides. So HI and JK are opposite, so those need to be equal when I find the slope. So for that one, HI is going to be y minus y, so negative 3 minus negative 1, over 4 minus 9, and so that's going to be negative 2 over negative 5, which becomes 2/5. Okay, let's find JK now. So that's going to be y minus y as well, so 3 minus 0 over 8 minus 2. And so what I get is 3 over 6. Well, that's 1/2. So when you look at those two, HI is, I'm going to double check my work here, but it looks like those are not parallelogram because opposite sides are not parallel. So I didn't even have to find that last pair of sides because I already found HI and JK were not parallel. Okay. So moving on to this last section here, and then we'll go to the next page. Each quadrilateral is a parallelogram. Find the values of x, y, and z. So if it's a parallelogram, we have those properties for each parallelogram. Okay. Opposite sides congruent, opposite angles congruent, all that good stuff. So in number 9, if this is 35, opposite of that is going to be 35 as well. So opposite of 35, x equals 35. Okay, well, if that's 35 there, okay, if we're looking at z here, so 75 minus z, or sorry, 180, because those are supplementary, so 180 minus 75 is 105. Okay, so 180 minus 75 is 105, and therefore z equals 105. And then to find x, or we already found x, to find y, we can kind of just look at this triangle here. I already said this was 35, and so since I have a triangle there, I can just add those two together and subtract from 180. So 75 plus 35 is going to give me 110, and so 180 minus 110 is going to give me 70. So y equals 70. So you can always use the triangles that are created from these different things, okay? From these parallelograms, quadrilaterals, whatever it might be, all right? So for the next one, it says, what values must y and x have in order for each quadrilateral to be a parallelogram? So for number 11, it says UD, so this right here, is 2x plus 1. Okay, so I'm going to go ahead and label that 2x plus 1. All right. And then RD is 15 minus y. 15 minus y. And then it says UT. Okay, UT is the whole thing there. UT is 26. And then DE is this, just that part, which is 5. Okay, so the easy one I see right now is that, okay, parallelograms have bisected diagonals. So this one, so DE and RD are congruent. So 15y minus y equals 5. And then I go ahead and get y by itself. So negative y equals negative 10. Therefore, y equals 10. So there's the first one. And then it said this whole thing was 26. So if it's bisected, remember I can say this is 2x plus 1 here. So 2x plus 1, 2x plus 2x plus 1 equals 26. Or I can just say, okay, well, if that's 26, both of these sides are 13. So either way, I'm just going to say 2x plus 1 equals half of it, 13, and then find that. So 2x equals 12, and I get x equals 6. And there we go for number 11. So we're trying to do the same thing for 13. What does y and x have to be for this? So in this case, well, first, opposite angles are congruent, so 5y equals 75. That's easy. Just got to divide by 5. 75 divided by 5 is 15. And then, since it's a parallelogram, I know these two angles are supplementary. So I can say 4x plus 15 plus 75 equals 180. And then I solve from there. So that would be 4x equals 90. Okay. And then, plus 90. 4x plus 90 equals 180. And then I subtract 90 to both sides. I get 4x equals 90. And divide by 4. X equals, and I'm running out of room here, so I'm going to go up here. X equals 90 divided by 4, which is 22 and a half. Okay? And I'm going to check my work real quick. 22.5 times 4 plus 15 is 105, plus 75 is 180. So it all checks out. All right. So moving on to number 15 here. It says, if ABCD is a parallelogram with measure of angle D equal to x and measure of angle A equal to 6x plus 5, find the value of x. See the figure below. So if I'm using this figure below, okay, I've got angle D is x, angle A is 6x plus 5. So just as we just did, those are supplementary. Those are consecutive angles. So therefore, 6x plus 5 plus x equals 180. They're supplementary. Okay? So combine like terms, I get 7x plus 5 equals 180. And I end up with 7x equals 175. And so I divide 175 divided by 7, and I get 25 for x. Find the value of x. That's all I had to do. So always double check. What was I trying to find? Just x, or do I need to plug it in? Okay. So number 17 says the measure of the bases of a trapezoid are 12 and 18. What is the measure of the median or the mid-segment? So mid-segment's what we've been calling in class. Okay, so if I've got a trapezoid here, actually I'm going to draw that a little bigger. So here's my trapezoid. Got 12, got 18, and it wants me to find this. Okay, so what we talked about in class is that the mid-segment is the sum of the two bases divided by 2. Okay, so in this case, it's going to be x equals 12 plus 18, the two bases, all divided by 2. And so that's 30 divided by 2, which is 15. And that's it. Okay, so again, that's going to be a formula that you're given on the test, so you don't have to memorize that. And then number 19, last one from this page. In a rhombus, what kind of triangles are formed by diagonals? Good question. So a rhombus, remember, is something like this where all 4 sides are congruent. And then a rhombus also has perpendicular diagonals. Okay? So we have something like this. Okay? Can do better with that right angle here. All right. So all 4 of these are congruent. Okay, and looking at their diagonals, I am making these two, so the outside is congruent. However, it doesn't necessarily mean those two are congruent. So all we know is that those triangles are right triangles. Okay. They're not going to be isosceles unless it's a square. Okay? So, the most important thing to realize there is that the diagonals are perpendicular. So, last page here. Number 21, what value must x and y have in order to be a rectangle? Okay? So, rectangle, keep in mind your properties is that it's a parallelogram and it has perpendicular sides. So, TLZ is right here. That's x plus 10. And then ZLP is 3x. Okay. And then it also says TZ right here is 4y minus 2. And it says LF, so the whole thing here, is 6y plus 4. Okay, find x and y. So in this case, starting with the x's, I know that these two together make a right angle. Okay, so that one's easy. I can just say x plus 10 plus 3x equals 90. So that's going to be 4x plus 10 equals 90. Subtract 10, and I get 4x equals 80. And that's going to give me x equals 20. Okay. Now looking at the pink, this is saying this whole thing is 6y plus 4. But in a rectangle, the diagonals are congruent, so that whole thing is 6y plus 4. So really, I can just add 4y plus 2 plus 4y plus 2 equals that whole thing. So 4y plus 2, or minus 2, plus 4y minus 2 equals 6y plus 4. So combine like terms, I get 8y minus 4 equals 6y plus 4. And now I can go ahead and get y on the same side. That's going to give me 2y. Add 4 to the other side, and I get 8. So divide by 2, y equals 4, and there we are. That would make it a rectangle. Okay? So again, those properties are very important to refer back to while you're going through these different things. Okay? So a few left here. Number 23 here, find the following values even given a rhombus ABCD. So, again, rhombus means all the sides are congruent and the angles are perpendicular in the middle. So, given that AEB, which is right here, is 3x, find x. Well, if it's a rhombus, that is a 90-degree angle. So all I have to do is say 3x equals 90, divide by 3, x equals 30. Done. Okay? But again, that has to be something you know or refer back to on your formula sheet. And then number 25, given measure of DAC, okay? So this is for the same picture. Actually, I'll just do a different color here, not to confuse you. All right, so DAC is this angle right here. That's 3x. All right, and then DAB, so the whole thing there is, so that's the whole angle. DAB is 4x plus 10. Find x and the measure of DAB. All right, well, if it's a rhombus, that means those angles are bisected. So if that's 3x, this is also 3x. So in that case, 3x plus 3x is going to give us the whole angle, 4x plus 10. And so that's going to give us 6x equals 4x plus 10. Subtract 4x to both sides. That's 2x equals 10. Divide by 2, and we get x equals 5. Okay. And the last two, number 27. This is an isosceles trapezoid, which means these two angles, or these two sides are congruent. It says ZDI, so this angle here is 35, which means this is also 35. Then the measure of ZOI, so this up here, is what? Well, if that's 35, these two angles are supplementary. So 180 minus 35 is going to give me that measure, which is, 145. So 145 is my answer for that one. Okay? And then number 29, same thing we did before. What kind of parallelogram is this? This is one we're going to go ahead and do in class. So keep that in mind as we go, okay? And that'll be on the other video, I think. So as you go through this, again, if you have questions, email me or ask me during class, and I can get right back to you so we can be ready for our test. Peace.